Let's look at this question. Virgin, again, I don't have the answers to this, so if you want to take notes, please do. Virgin Airlines is considering the expansion of its services to South America. Due to political uncertainty, there is a possibility that airline ticket prices will be regulated by South American governments, which would make the project extremely unprofitable. The decision tree for the project is like this. So you invest in the project for $65 million. There might be regulation. If there's regulations, then you make $5 million. After that, you can abandon the project for $20 million, or you stick with the project. 40% of chance you're making 25, 60% of chance you're making 35. You're losing 35. No regulation case. Again, you can abandon the project for 20 million. You can stick with the project for nothing. And then if you stay with the project, you're either making 120 or 60. Again, I will ask you to find the NPV of the project without having the abandonment option. So ignoring the abandonment, what is the NPV of the project? Again, I want you to calculate it. So what is the NPV of the project? Ignoring the option to abandon is the first step, which is the easy step. So what am I going to do? I'm going to calculate the value of the upper branch and value of the lower branch. I'm going to discount those, and I will find the NPV. Okay, so when we are in the upper branch, I have 120 with 60% chance. And with 40% chance, I have 60. Okay, so this happens at time 2. I need to discount at one period by the discount rate, 115. So now I'm at time 1. At time 1, with the no regulation case, I have $10 million. Then, having this happens with the probability of 80%, right? With the 80% chance, I will be in the upper branch. Okay. Plus, look at the lower branch now. With 40% chance, I'm going to make 25 million. With 40% chance. And with 60% chance, I'm going to lose money, which is minus 35. This happens at time 2. I'm discounting it one period back. Now I'm at time 1. In the regulation case, I'm making 5 million. So I'm going to add this. And the probability of having going to the lower branch is 20%. So this is time 1. I'm interested in NPV, which is time 0. So I'm going to discount those one more period. Then I need the initial cost that I need to consider. So NPV of the project will be equal to minus 0.766 without the option of abandonment. Again, you need to be very comfortable solving NPVs. It's the easiest part. It's the first step to the question. Any question? Just be careful about where you are at the timeline. The only thing you're doing is multiplying probabilities with the profits. That's it. Okay. Now, let's introduce the option to abandon to the picture. So what am I going to do? What do I need? I need SU, SD, and S. So what am I going to do? I'm going to focus on SU first. In the SU case, what do I have? If I don't abandon, okay, you can abandon or not abandon. If you don't abandon, you're making 120 with 60% chance. and you're making 60 with 40% chance. Okay. This happens at time 2. I'm taking it to time 1. So this should give you 83.47. So this is SU. Then I need to find SD. Okay, in the SD case, what do I have? I have 25 times 40% chance you're making 25 million. 60% chance you're losing 35 million. Again, discounted by the discount rate. So it's going to give you minus 9.565. Then I need to calculate S. Okay. How am I going to do it? With 80% chance I'm in the upper branch. So I have SU. And with 20% chance I'm in the lower branch. This is SD. And then discounted 1 period to bring it to time 0. So S will be equal to 56,408. If you remember the risk-neutral probabilities case, actually you have those formulas there as well. We kind of did those. So you're multiplying the probability of upper branch with SU. You're multiplying the probability of lower branch with SD. And then you need to discount it because we're taking time 1 SUs and SDs to time 0. So this is S. Now what am I going to do? This is the option of abandonment. It's like a put option. So when you when you exercise the put, you sell the stock at the strike price. Here, you're not selling a stock, but you're abandoning the project. You're selling the project for 20 million. So what am I going to do? I'm going to compare those values, SUs and SDs, with 20 million I can get when I sell the investment. Does it make sense to you? If you remember, the payoff was maximize strike price minus P or 0. So you have the up case or down case. So for PU, this is what am I going to do? I'm going to compare the value of the investment when you sell the investment with sorry, this is S. With the stock price in the up case, and I'm going to do the same thing for the down case. Did you write it down? Can I? Okay. So what am I going to do? I need PU and PD. Oops. Okay. So PU is going to be max 20 million. And SU was 83,478 or 0. So if you're in the upper branch, you're expecting to make $83 million. But if you sell the investment, you can make 20 million. Would you exercise the option? No, right? You get 20. If you abandon, if you don't abandon, you expect to make 83. So no. In the down case, you're comparing your the money you're gonna get if you abandon the project with SD this time, and SD was minus 9.5. So in this case, would you exercise the option? Yes. So instead of losing 9 million, you're kind of saving that loss. On top of it, you're getting $20 million. So together, PD will give you this. After that, you need to calculate delta, which was, if you remember, what was the formula for those? Okay, let's look at this. Okay, so this is PU minus PD over SU minus SD. So just plug in the numbers. I'm not going to write them, but it's going to be minus 0.318. And you can calculate the borrowed rate, which is sorry. And the risk-free rate here is, I forgot to tell you, it's 4%. So the discount rate is 15%, risk-free is 4%. Please be careful. We are using discount rate to discount the value of the cash flows. Why? Because discount rate gives you your minimum acceptable return for a project like this. So discount rate is investment specific. Remember, this B is about borrowing rates. It's about borrowing money. And we assume that you borrow at the risk-free rate in the economy. This is our simplifying assumption. So from here, borrowed rate will be this. And P will be, what is the P? So from here, P will be. Okay, now the question is, the NPV of the project was how much? Do you remember it? It was minus 0.76. The value of the abandonment is 7.5. Would you take the project if you had the option to abandon in the future? Yes. Why? Because NPV star, which is NPV without the option to abandon, plus the value of put, is positive now. So it was minus 0.766 plus 7.581. So NPV star is equal to, again, the idea is same. When I introduce the option to abandon to the picture, you're not stuck with this investment forever anymore. You can abandon when things are not going well. And you turn a negative NPV project into a positive one. The idea is the same. Any questions about Virgin Airlines? Okay. Is it straightforward to you, or are you kind of getting lost? Okay, good. How many? Okay, I think I have only one more question about abandon, and then I'm going to stop. And next week we're going to talk about, oh no, I don't need to stop. We're okay. No, I will continue. I will do stage investment as well, and then maybe I will stop. Okay, let's look at another example. Okay. Assume you're the CFO of a chain gourmet food stores and you're considering opening a new store in the recently renovated Ferry Building in New York. This will be kind of different than what we did before, but I just want you to be comfortable with different ways of looking at things. The intuition is the same. If you don't sign the lease on the store today, someone else will, so you will not have the opportunity to open the store later. So you have to definitely sign the lease today if you want to make the decision. There's a clause in the lease that allows you to break the lease at no cost in 2 years. So after 2 years, you can abandon the project. Including the lease payments, the new store will cost $100,000 per month to operate. Okay, so I have monthly cost. So there are two things that can happen. This area might be really in. If it is the case, there will be lots of traffic, pedestrian traffic. And in this case, you're going to make $8,000 per month in perpetuity. So now I'm introducing perpetuity to the picture, not the decision trees. If, however, the building becomes a tourist attraction, you expect to generate $16,000 per month in revenue in perpetuity. So basically, this is like an infinite life project. You have to make the decision now whether you want to open the store or not. And after 2 years, you can abandon the project. So what am I going to do? I will calculate the NPV of the project, NPV of the options and everything. 50% chance ferry will be ferry area will be a tourist attraction. So in that case, I'm going to make $16,000. 50% chance it will not. So in that case, I will make $8,000. The cost to set up the store is $400,000. The risk-free rate is 7% per year. Since everything is in months, I'm converting the annual interest rate to month interest rate. by dividing it by 12. That's it. 7 over 12 minus, 0.565 is the monthly interest rate. So did we understand the question? Okay, just a recap. Your, what was the investment? I didn't even, okay. You're thinking about opening a store at an area. The monthly costs are $10,000. This investment has infinite life, perpetuity. So cost will be in perpetuity, revenue will be in perpetuity. But after 2 years, after 24 months, you can sell the store. You can close the store. Oh yes, which was how much? $400,000. Thank you. You have to pay $400,000. Okay. So what am I going to do? I'm going to calculate the value of this investment, basically. The idea is the same. So basically, if you open the store today, you're making the decision today, there are two possibilities. It can be a tourist attraction with 50% chance, or it will not be a tourist attraction. So in that case, your expected revenue will be $12,000 a month. Okay, just expected profit per month in those two cases. So how do I calculate MPV? I'm making $12,000 a month. It's perpetuity, so it's cash flow over the interest rate, right? Remember perpetuities? Okay. And I have a monthly cost of $10,000. So, and I have the initial cost of $400,000. If I calculate the MPV of the project, it's going to give you negative $46,000. Did you understand what we did? I calculate expected profit per month. 50% chance you make $8,000, 50% chance you're making $16,000. So your expected profit each month is $12,000. Your monthly cost is $10,000. These are at time 0. Why? Because you start making money starting next month immediately. So this is the cash flow at time 1. You divide it by the interest rate, perpetuity formula. This is the value at time 0. This is the value at time 0. This is the value at time 0. So you're losing money. It's a bad project. You shouldn't open the store. But I have the option to abandon the project after 2 years. So now let's see how things will change. So now this is what's going to happen. You decide whether you open the store or not. After you open the store, it can be a tourist attraction or not. And then 24 months passes, and you have another decision. You can keep operating or you can shut down. So now let's see how this flexibility will change things. So if the ferry building becomes a tourist attraction, what is my MPV? I'm making $16,000 a month. So the MPV in the tourist attraction case will be $661. Okay. If the ferry building doesn't become a tourist attraction, then every month you're making $8,000. Okay, now we're going to turn into, we will turn things into annuities. So remember, your decision to close the store comes after 24 months. And if this building doesn't become a tourist attraction, for 24 months, you're stuck with $8,000 profit. So now this is the present value of annuity formula. You have 24 months. You have monthly interest of 0.56. And you have monthly revenue of 8,000. So for those 2 years, this is how much money you're going to get. And for 2 years, this is how much cost you're going to get. Every month you have $10,000 cost. And I have the initial cost. So if the ferry building doesn't become a tourist attraction, you're going to lose $444,000. So there are two cases. If it becomes a tourist attraction, you're going to make $661. If it doesn't, then you're going to lose money, $444,000. Okay. So I know that there's an equal probability of the ferry building becoming a tourist attraction or the ferry building not becoming tourist attraction. So 50% chance the MPV will be 661. 50% chance the MPV will be minus 444,000. So the MPV of this opening store is actually $108,000. Because after 2 years, you have the option to sell. So as you can see, it was a negative MPV project without the option to close the store after 2 years. With this flexibility, with optioning, with having option of closing the store in 2 years, you basically increase the MPV. The MPV became 108. The difference between these two is the value of this put option actually, 154. So with this last example, I did things in a different way. But we are still in the options idea. We are still thinking about having the flexibility and how much value it's going to add to the picture. Any questions here?
Can you repeat the case of the not being true set action?
Sure. Here, in this case. If it doesn't become a true set attraction, you're going to have the option to sell the ferry building. Things are very simple here. I didn't give you any monetary value of selling the ferry and stuff. But if for 2 years, if you get $8,000 revenue every month, then you calculate the MPV of this investment, and it's going to be negative. Because if it doesn't become a tourist attraction, you're stuck with it forever anyway. But at least after 2 years, you can sell this. So I'm going to calculate the MPV of the project just focusing on 2-year loss, basically. Otherwise, I will have more loss, of course, if I don't close the store. So in that case, MPV will be negative $444,000. What part should I repeat? Do you understand why I'm using annuity now? Because it's a 2-year project now. After 2 years, you're selling it. So it has finite life. And the rest is just present value of annuity formula. This is for the revenue. This is for the cost. And monthly cost. This is the initial cost. Anything else? Okay. Do you want to go over one more question? We have to do this. No? Let's go over this, and then next week maybe we're gonna finish early. Okay, let's read this. It will take just like 10 minutes. Okay, it's blah blah blah. So I will read it. Finance Research Services is considering expanding their operations to Europe. This time, this is not abandonment, it is stage investment. It will be difficult to penetrate the European market. There is a high risk of failure. Due to this risk, the company is considering expansion in 2 stages. The first stage would be small and would serve to establish a foothold in Europe and judge the potential profitability of full-scale European operations. Following the first stage investment, FRS will have the option to complete the second stage investment that would establish full-scale operations in Europe. Okay, the first stage of investments cost $20 million in year 0, like a startup cost. There is 40% chance that demand will be high, 60% chance of demand will be low. If demand is high, we are making $4 million. If the demand is low, we are losing $2 million. After the first stage, FRS will have the option to invest in the second stage. The second stage costs $100 million, additional cost. Given that demand was high during the first stage of the investment, so basically this is what it's saying. So you can have high demand or low demand. And in the second year, you have the decision to invest in stage 2. In that case, you will either have 180 or you will have 50. Or you don't have to invest. If you don't invest, you're not making any money. If there's low demand, again, you can make 50 million or lose 30 million based on different probabilities. And if you don't invest, then you're not losing any money. So now, again, the only difference is instead of talking about option to abandon, we're just focusing on optioning of stage investment. So in the first part, we will again calculate the MPV of the project without having the option to invest in stage 2. So the last time today, I wanted to calculate the MPV of it with the last bonus, if you're interested in bonus, and this is actually the easiest one. So first, we will calculate the MPV of the project. ignoring the option to have the second stage of investment. So probably you cannot see it, but I will tell you. So basically, if you don't have investment in the second stage, you're basically here, right? This is a one period thing, because in the second period, you don't invest and you get 0 and 0. So for that, we will just focus on time 1. Thank you. And then we're going to discount it for just one period. So NPV will be like this. With 40% of chance you're going to have high demand. In the high demand, you get 4. And then with 60% chance you're going to have low demand. If you have low demand, you're losing -2. You're losing 2 million. And this happened at time 1. You're discounting it for one period. And the initial cost is -20. So basically, this is going to be -19.636. So this is the NPV of the project if you don't have stage investment opportunity. So it's a negative NPV project. You say no. Okay, now I'm going to introduce the option of having stage investment. Then what am I going to do? Again, I need to calculate SU and SD. Okay, so what am I going to do? In the SU case, I will focus on here. With 60% chance you make 180, 40% chance you make 50. In the low branch case, when you do the investment, you will either have 50 or you're losing 30. Okay, so we're going to do what we did before. SU will be equal to, let's do it, 60% chance you're making 180. And 40% chance you're making 50. These happen at time 2, so I'm discounting it by one period. Again, I don't have the answers on the slide, so take a note if you want to have the answers. Okay, so SU will be this. And similarly, I will calculate SD. So 30% chance I'm making 50, and 70% chance I'm losing 30. Again, discounted by one period. So I'm going to have -5.455. And then I need to calculate S. For S, I have 40% chance of being in the upper branch. In that case, SU is this. And 60% chance I will be in the down branch. Again, these are at time 1, so I need to discount it by one period. So S will be equal to 39,339. In the break, Bartu asked me why we are ignoring low demand and high demand cases, like those profits, $4 and -2. Why are we doing this? Why do you think we don't include those in our calculations? Because in
You already calculated.
thank you. In the first, you listened to my answer though during the break. Okay, you're right. Exactly. When we calculate NPV, we are already including these in our analysis. And I'm only interested in the value of stage investment now. So on top of the original NPV, I'm adding the option of flexibility. Okay, after this, what else do I need? I need CU and CD. This time, this is a call option case. So I'm going to compare how much money I need to pay compared to how much money I can make, right? So remember, let's move here actually. Okay, so if you remember, CU is max, the difference between what the stock price is and what the strike price is. Okay, so if you decide to invest in the second stage, you have to pay $20 million, just like the call option. If you decide to exercise the call option, you have to pay the strike price. So the idea is the same. So CU will be what? Maximize. SU was 116364. If you do stage investments, how much money you need to spend? $100 million. So in that case, would you exercise the option? Yes, it's profitable. So CU will be this. Then you need to calculate CD, the same logic. In the down branch case, you're losing 5,455. On top of it, you need to pay $100 million for the investment. Would you consider this? No, it's a bad decision. You're going to lose money anyway. So after that, the only thing you need to do is calculating delta. Plug the numbers in the formula, so I'm not going to do it. Let me just give you the answers. Borrowed rate will be minus this, and the value of the call, which is the value of stage investment, will be equal to 5982. So if you remember, MPV was negative before. It was minus 19,636 plus the value of having the stage opportunity, the value of the call. So it's going to be minus 13,654. So is stage investment is investing in the project a good thing? No. Even having the flexibility for stage investment couldn't save the investment. So it's a bad investment. FRS shouldn't go with the investment. Any questions? Then we're done for today. We're going to continue next week.